Helloskis! In this video, I'm going to be going over 10.3 geometric series sequences, same difference. In this is just like arithmetic series when we added and subtracted to get to the next term, but instead we are going to multiply or divide, multiply by a common ratio. The common ratio could be 2, it could be 1/2. Notice if it's 1/2, you're going to be taking your numbers and kind of dividing by 2, same sort of deal. But you're going to multiply by the common ratio r to get to the next terms. In order to write an explicit formula for this, you would have a sub n is equal to a sub 1 times r to the n minus 1. And a recursive, since you are multiplying your previous term by the rate, that would be your recursive formula. So let's go ahead and look at a few examples and see what I'm actually talking about when I talk about geometric sequences. So in this example, it's asked for determine the common ratio, so I know that this is a geometric sequence since I'm talking about a common ratio, and find the next three terms. So in part A, I noticed that my first term is 4, my next term is negative 12, and I know I had to multiply by some number to get there. Well, that number that I had to multiply would be, what, negative 3, so here my rate would be negative 3. And then same thing there, right? Same ratio. So, cool, common ratio is negative 3, and if I continue to multiply by negative 3, well, 36 times 3 is 90 plus 18, so I have negative 108. And then I have 324, and then that times 3, well, 24 times 3, oh gosh, 900 plus 48, 72, so 972, but it will be negative. Cool. On the next one, it looks like from 1 to 1/2, since I have to multiply by something, it multiplied by 1/2. Same thing from 1/2 to 1/4, so my common ratio then is 1/2. And to find my next terms, I would have 1/8, 1/16, and 1/32. Cool. In the next one, I have from 50 down to 10, so it looks like it divided by 5, so that would be the same thing as multiplying by 1/5. Did the same thing there, the rate was 1/5. So I have, the common ratio is 1/5. To get my next term, I have 2/5 x. The next term after that, multiply it by 1/5 again, so 2 over 25x. And then I will have 2 over 125x. Yay. Alright, and in this one, it's asking for the explicit and the recursive formula for finding the terms. Right, Dakota? Haha, you're in it. Don't cuss. George Lucas did. Bad George Lucas. Okay, so with this, we know our formula for the explicit is a sub n is a sub 1 times r to the n minus 1. So really I just need to find the rate, and I have my first term. This one, it looks like the rate is 1/3. So I'm going to say 1/3. So for my explicit, I have a sub n is the first term is 36. So 36 times 1/3 to the n minus 1. Oh, happy day. And then for your recursive one, you have a sub n is 1/3 times your previous term. Cool. Next one, it is multiplying by negative 5. Banana phone. Eat some potatoes in Mananabdone. I don't know what that says. Yeah. You have your first term, you have your rate to the n minus 1. And for the recursive, it is being multiplied by negative 5, so negative 5a to the sub n minus 1. Cool. Happy day. They're whispering and they don't think I can hear them. But I can hear you, and I'm telling you I can hear you. What I said. That was a good joke. I am great. That's why they call me George Lucas the Great. Oh no, that means I cussed. Doesn't matter if it's George Lucas Day. That's right, and don't come back to that. Yay? Yay. How about now? No. Okay. Just checking. Bananas are yellow, oranges are green. Monkeys like bananas. He made a good one? What was his rhyme? Yeah. Yeah, it's a pretty good one. Okay, in these two, find the specified term for the geometric sequence. That says a of 9, a sub 9, not a sub g, a sub 9 for this sequence. Well, there's my first term. It looks like the rate is multiplied by 2, so my rate is 2. So for my formula, I can say a sub n is 20 times 2 to the n minus 1. And now it's just a matter of substituting in 9 for n, so I can say a sub 9 is 20 times 2 to the 9 minus 1, which is 20 times 2 to the 8th. I think 2 to the 8th is 48. No, it's not. 4. Maybe it's 256. Hang on, bananas in pajamas. So we got 2/8 times 20 is 5120. So my ninth term is 5120. Oh, happy day. Okay, the next one is asking us for a sub 7, and it's giving us that a sub 10 is 200 and the rate is 2. Well, if I have a sub 10 already, I could find a sub 9 and a sub 8 and a sub 7 would be simple to find. So if I have 200 and it multiplied by 2, if I divide by 2, that's 100, then that's 50, then that's 25. Oh yeah. So someone told me that their favorite animal was an elephant, so there's a monkey dressed in an elephant costume. Okay, there are two geometric sum formulas. So as long as you have a geometric sequence, or something that looks like a to the first to the r times r to the n minus 1, you can use a geometric sum if you are trying to find the sum of a sequence. So that formula is a sub 1 times 1 minus r to the n over 1 minus r. If it is an infinite or it goes on forever, you have a sub 1 over 1 minus r. So we could use those formulas when we are doing something like this. Have the first 6 terms of this sequence. It looks like the rate is 3. I have my first term is also 3. So for the formula, a sub 1, so a sub 1 is 3 times 1 minus the rate to the 6th, since I'm looking for the first 6 terms, all over 1 minus 3. And it's just a matter of being very careful when you are substituting these numbers into your calculator. So you should be getting the answer 1092. If you are not, check something, make sure you're plugging in your calculator right. If you're not getting that, try plugging in a different way. I will show you what I did. What I did was 1 minus 3 to the 6th, and then I divided that by negative 2 because 1 minus 3 is negative 2, and then I multiplied that answer by 3. Okay, and one like this, I notice I have from terms 1 to 7, and it gives me my first term. That's your a sub 1, that's your rate. So you can say the sum of the numbers is your first term, so 144 times 1 minus r is negative 1/2 to the n, which is 7, all over 1 minus negative 1/2. And again, just be careful when you're plugging it in your calculator. So hopefully you should get 96.75. Happy day. Okay, these two, we're finding the sum of the infinite geometric series, so notice you have a different formula for that. Sum of the infinite series is your first term over 1 minus r. So in this instance, I have my first term is 1/2. So I have 1/2 divided by 1 minus my rate, which is 3/8. Substitute those numbers in your calculator. Banana phone. Okay, and we get 0.8, so that is also 4/5. So if you write 0.8, if you write 4/5, happy day. Okay, this next one, notice your rate to get from one term to the next, the rate is negative 2. Well, if you think about that, won't the next term be 16, and then it'll be plus negative 32, and then plus 64, and then plus negative 128? Notice those numbers continually get larger. So if they keep getting bigger, it's just going to keep adding more and more numbers to your sum. So this one would actually have an undefined sum. because the numbers just keep getting larger and larger. Basically, you are going to have a sum that is undefined when you have a rate that is bigger than 1. So if your rate has to be between -1 and 1 for anything to be actually defined as like 0.8 or 4/5 or something like that. You may come up with an answer if you plug it in your formula, but since the numbers keep adding, get larger and larger, there's not actually a definable sum to the infinite sequence. All right, lastly we're going to be looking at. In this one we are finding the common ratio. We're given the third term, we are given the sixth term. So I have that the third term is 12, I'll have the fourth term, fifth term, and sixth term is 187.5. So notice here, you did the rate once, you did the rate again, and you did the rate one more time. So you did the rate, multiplied it 3 times. So we know that the rate cubed is equal to what number I multiplied to get from 187 or from 12 to 187. So what I can do is say 187.5 divided by 12 is a magical number, 15.625, 15.625. And now to find r, you can take the cube root of it. Cube root, if you do not have a cube root function in your calculator, or if you have a greater root, if the difference is bigger than 3, you can say that this is 15.625 to the 1/3 power. So that would look something like this. 15625 raised to the 1 divided by 3 power. And we get 2.5. So there's our common ratio. And if you don't believe me, you can multiply 12 times 2.5. So let's see, 12 times 2.5. Do it again. Do it again. Hey, look. After 3 times of multiplying that number, I come out with 187.5. Yay. Doing the same thing here. Notice here, though, from 4 to 5, it multiplied the rate. 5 to 6, it multiplied the rate. So I have r squared equals the division of these two, so -1372 divided by -28. So the difference is 49. So 49. So then my ratio could be either plus or minus 7 when I take the square root. Cool. Hopefully this video has been helpful for you guys. I love you. I will see you in class, hopefully. Bye-bye!